Okay, so today we're going to look at, we're starting chapter 9. So 8 and 9 are the only chapters of this topic. So what we're going to look at now is when we have a combination of a growth and decay scenario. Because this essentially is when you have the combination of a growth and decay, what that essentially is generally like a lot of practical applications, like a loan. So if you think about it, the growth is the interest you have to pay, say pay the bank, and that's the growth. So you'll see that like the recurrence relation would have one of those R values, and because it's growth, it'll be, say, something like that, 1.02. That's an example, okay? So it would be growing by 2%. So you borrowed this money and the bank's charging you 2% compound interest. The decay part, you'll see, and then you'll have a decay. And what the decay part will be, you know, you're minusing an amount. And what that is the payments that you're trying to make for the loan, and you're trying to reduce it. So you can see it's a combination of, yes, it's growing, and but you're trying to decay. So we're just looking in 9A. We're just talking about basic. We're not putting the application into it, but that's where we're going. So we're just talking about having a recurrence relation that has growth and decay. So you can see here on this little application where it says, write down the first 5 terms generated by the following recurrence relation. So there's 50. You can see this 2 is the growth. So you've got to double it, and then this 10 is the decay. So you can just type it into your calculator like we normally do. You know how we press 50 and we press enter? And then if we go times 2, it ends up saying answer 2, and you go minus 1. So 50 times 2 would be 100, minus 10 would be 90. So you can see here, and you can keep pressing enter, and you'll get the first, it said write the first 5 terms. So 1, 2, 3, 4, 5. When they say write the first 5 terms, V0 or T0 is a term. So we do include it as one. I know it can be a bit confusing. Don't worry, the exams never like iffy like that. All right, let's just do this example here. It says the trout in a fish farm pond after n months can be modelled by the recurrence relation. So here you've got this growth here. So you can see the 1.1 is the growth. And what that might be, so in this scenario, it might be like the fish are breeding and they're growing. But then all of a sudden you have like, it's a trout farm, so I think people come and fish or take them away. So here's the decay, and that's like the people fishing, or I don't know, people, you know, taking them out or dying or whatever. So that's the decay part. So there's another scenario. So use the recurrence relation to determine the number of trout in the pond after 2 months. So we can just simply do that in our calculator. I'll pause it and we'll do it. Okay, so we quickly saw on the calculator we had TO was 10,000. We've got T1 by timesing it by 1.1 and minusing 3,000, so we got 8,000. T2 was 5,800. So there was the answer to after 2 months. And then for part B, when it said how many months did it take to be no trout left. So we saw that was T2, T3, T4, just to show you, we got 7, 18, and T5, we were in the negatives. So we're going to say after 5 months. Okay, so our answer will be after 5 months. Okay, we're going to round it, happens somewhere in there. Okay, so here's a little exam question. Consider the recurrence relation. The recurrence relation could be used to model. Now, I just put it in there to help you think about it. But we're really here, is that growth or decay? That's growth. And what about this next bit? Is this bit growth? Yeah, that's growth too. So we shouldn't see any decaying, scenarios. So a reducing balance depreciation. Well, is it reducing? No, so get rid of that answer. A reducing balance loan. Now remember, a loan would grow because you've got to pay the bank. So a loan would have growth, but you're reducing it by making payments. Is this payment? This is not a reducing payment, is it? No, so that one's out. Okay, we haven't learned about a perpetuity, but a perpetuity is when the growth and then what you take away, the decay, is the same amount as the growth. So there definitely is no decay there. And an annuity, now this one could be, we're going to see these in a minute, so I'll just go through it with you. An annuity is an investment, so that means you're gaining money. So you would see the growth. And so it's like you've got an account, you're put some money in, it's getting in interest, compound interest, and then they're saying you're going to add extra payments. Well, does that look like that would be? If you think of the value of your investment, that would make sense, wouldn't it? Because you're adding extra. So that ends up being the answer. An interest-only loan, you'll have a look at that later on this week. So an interest-only loan is when, once again, the decay, the payment will match the growth. So that one wouldn't. So there's only one answer that had the two growths in there.